In this video, I'm going to solve a couple of examples based on the electric field. So here is the first example. Here he's asking about the given data. The surface charge density of an infinite charged plane is negative 2 times 10 to the power of minus 6 coulombs per meter square. So he's talking about an infinitely charged plate. Okay, and he gave us the charge density. So coulombs per meter square. So basically he gave us sigma or eta. That value is minus 2 times 10 to the power of minus 6 coulombs per meter square. A proton is shot straight away from the plane at 2 times 10 to the power of positive 6 meter per second. So he gave us velocity. Initial velocity is of a proton which is shoot away from the surface at 2 times 10 to the power of 6 meter per second. Now the question he's asking about, how far does the proton travel before reaching its turning point? So what is the maximum height it can reach? In physics, the most difficult part, I would say, is converting the words into visualization. Okay, once you draw a simple picture, I believe it will be easy for you to understand better. So I always try to draw the picture of what he's talking about. So here an infinitely charged, negatively charged plate is placed and charge density is given. A proton is shot, so it's traveling certain height. So what is the maximum height it can reach? He gave us initial velocity. So we need to assume few things, which is the final velocity. Definitely once it reaches to the final point, the velocity is going to be 0, so it will start falling down. And another thing he didn't give us, the mass of the proton is 1.67 times 10 to the power of minus 27 kilograms. You don't need to remember this, but definitely if I ask you this kind of questions, I will definitely give you the data in the equation sheet. So we know that E equal to F over Q, or F equal to E times Q, which is from the electric field, and F equal to M times A, which is from the Newton's law. So we know the E value, we know the Q value. We don't know the E value, we can find E value. And we know the mass, we don't know the acceleration. So E equal to sigma over 2 epsilon naught or eta over 2 epsilon naught, we just found from the previous in the previous video. So that's the electric field because of a long disk of charge. Okay, so as I mentioned, he clearly mentioned it's infinitely large plate. So I'm assuming the height it can reach is very small compared to the size of the plate. So that's the reason I'm using this formula. Otherwise, we have to use a bigger formula. And just a reminder, if you have two plates like this, positive and negative, then electric field is E equal to sigma over epsilon naught. If there is only one plate, sigma over 2 epsilon naught. If there are two plates, E equal to sigma over 2 epsilon naught. It's just a reminder. We don't need to worry about this formula. Okay. Now I'm going to find the acceleration. A equal to EQ over M. I'm going to substitute sigma over 2 epsilon naught Q over M. So this is the formula I'm going to use. So sigma is minus 2 times 10 to the power minus 6. Q is 1.602 since it's a proton, charge of the proton. 2 is the number. Epsilon naught is 8.85 times 10 to the power of minus 12. And M is mass of the proton, which is 1.67 times 10 to the power of minus 27. So from this, I found the acceleration A equal to minus 10.83 times 10 to the power of 12 meter per second square. Okay, my goal here is finding the height it can reach. So I'm going to use one of the kinematic equation. Final velocity square equal to initial velocity square plus 2as or 2ah. Final velocity is 0 and initial velocity we know 2 times 10 to the power of 6 whole square plus 2 a, acceleration we just found, and h. Okay, so here if I move this to the other side, my apology, too many lines. Okay, so if I move this to the other side of the equal, we'll end up with negative 4 times 10 to the power of positive 12, and this is negative 21.67 times 10 to the power of 12. So here we have 10 to the power of 12 on the right hand side, 10 to the power of 12 on the left hand side, so they both get cancelled out, and negative get cancelled out, so this negative and this negative get cancelled out. We'll end up with h equal to 0.1845 meters or 18.45 centimeters. This is the first example. We already solved in the class, but I want to make a video so that it's a good practice for you guys later on. So here is the next example. An electron is launched. An electron is launched at 45-degree angle at a speed of 5 times 10 to the power of 6 meter per second from the positive plate of the parallel plate capacitor shown in the figure. So here is the figure. So you have a positive plate and a negative plate. An electron is shot with a 45-degree angle. Okay, that's 45 degrees angle. Here the electron landed 4 centimeter away. So the length of the plate is very big, but it is landed 4 centimeter away from where it is fired. Okay, the length could be more than 4 centimeter in this case. I mean, length of the plate, or I can say diameter of the plate is very big compared to the distance between the plate. So you can see D is very large compared to the length. He didn't give that information, but I'm assuming. Okay, as I mentioned, converting these words into a picture is little difficult, okay, in physics especially. So as long as you do it right, it's, I mean, almost 30-40% of the problem you already solved it. So the question he's asking about, what is the electric field strength between the plates, E value, as well as what is the smallest possible spacing between the plates. So that's the two things he's asking about. So we know that E equal to F over Q, or F is nothing but by Newton's law MA times MA over Q. F equal to MA, so MA over Q. Q here he gave us, that's an electron, so minus 1.602 times 10 to the power of minus 12 coulombs. Mass of the electron he didn't give us, which is 9.11 times 10 to the power of minus 31 kilograms. Mass of the electron is very small compared to the mass of the proton, around 1000 times approximately. Okay, now what I'm going to do, so here this electron is going to, I mean, they shoot at 45 degrees angle, right? They shot at 45 degrees angle with x-axis. So here we call this as a projectile motion. Okay, so in projectile motion, this electron will have acceleration 0 in the x direction. There is an acceleration in the y direction because remember we have positive plate down here, so it will attract. At the same time there is a negative plate up there, so it will repulse, so it will start falling down. That's called projectile motion in this case. Now so acceleration in the x direction is 0, acceleration in the y direction are definitely changing. So since there is no acceleration, it's a constant velocity in the x direction. So what we're going to find first, I'm going to find velocity or time taken to reach the final point. So it traveled 4 centimeter. I know the distance. I know v naught in x direction, or velocity in the x direction. So I just used velocity equal to distance over time in the x direction. So v naught times cos theta, because I'm just looking for x direction velocity, times t. So I found t equal to 1 point. So I substituted all the values. V naught x is 4 times 10 to the power of minus 2 centimeter, or meters, converting into meters, 4 times 10 to the power of minus 2. and velocity is 5 times 10 to the power of 6. That's a initial velocity. I'm converting into x direction, which is multiplied by cos 45. You will end up with 1.131 times 10 to the power of minus 8 second. That is the total time of travel. Now, so that's a projectile motion. The total time of travel is 1.13 times 10 to the power of minus 8 seconds. Then what is the time of travel to reach the highest point, which is exactly midway, right? So why am I finding that? Because I know the final velocity in the y direction at the midpoint. So that's the reason. How do I know I need to use that? That comes with the practice. Even when I was doing this first time, I confused myself. So not only in physics, anywhere, when you're studying something new, definitely your mind won't take it. It will take some time to understand the new concept. So you may need to study it 2-3 times to understand it better. Okay, so my goal is I want to know the time taken to reach the highest point, which is half of the total time of travel. I found that that value is 5.65 nanoseconds, or 0.565 times 10 to the power of minus 8 seconds. Now I'm going to use another kinematic equation. V final velocity equal to initial velocity plus at. Okay, so here I'm doing t by 2 because I'm talking about final velocity is at the midpoint in the y direction. So final velocity in y direction is 0 at the midpoint. So in the projectile motion, once it reaches to the midpoint, the velocity in y direction is 0. That's what I'm taking. And equal to v0 times y direction, which is 5 times 10 to the power of 6 sine 45 degrees. That's the velocity in y direction, plus a y, which is I don't know, I'm trying to find. As I mentioned, I used t by 2 because I know the total, I took this total time as t, so I just need time of travel till this point. So that's the reason I'm taking t by 2. Okay, other than that, it's not t by 2 in the main equation. So I found acceleration in the y direction, which is a negative 6.25 times 10 to the power of 14 meter per second square. So from there, I found the electric field E equal to F over Q. F is m times AY over Q. I gave you m value, mass of the mass of the electron, and AY we just found, divided by Q is minus 1 point charge of the electron. So electric field I found 3558 Newton per Coulomb, or 3.6 kilonewton per Coulomb. As long as your answer is very close to it, I will give you full credit. Even as long as you did the procedure right, but you end up with some wrong number, maybe I'll take out 2-3 points out of 30-40 points. Okay, so you're not going to lose much. So I'll give more value to the procedure, how you did it, not the answers. Okay, now, so the next question he's asked about, find the height. What is the maximum height it can reach? So here I'm going to use v final velocity square equal to initial velocity square plus 2ah. So all of them are in y direction. Okay, so final velocity in y direction when it reaches to the maximum point is 0, we know that, and initial velocity is 5 times 10 to the power of 6 times sine 45 whole square plus 2. A is minus 6.25 times 10 to the power of 14 times h. So if I substitute every value, I found out h equal to 2 times 10 to the power of minus 2, which is 2 centimeters. That's the maximum height it can reach. I'll stop this video here. In the next video, most probably I'm going to solve a couple of more examples. Thank you.